Hey guys, today we're going to be looking at simultaneous equations, right? So sort of the technique behind them and certain little tips and tricks we can use for exams. All right, cool. So I guess what are simultaneous equations and when do we use them? Before I get into a couple of practice questions, I want to go over the theory, right? So it's where essentially you've got, as the word simultaneous suggests, two or more equations at once in one question. You've got variables, the same variables in each of those equations that you want to solve. As the example is here, we've got two equations and two variables. So that comes to my first rule I want to discuss. It's not really mentioned, but it's just makes intuitive sense. So the number of variables that you are needing to be solved requires that many unique equations, right? So in this case, because we've got y and x, two variables, we need a minimum of two equations to solve it. I think in year 10 and maybe later years, you'll come across simultaneous equations where you've got three different variables and you'll need three equations to solve it. Just rearranging a second equation isn't sufficient because it's the same equation. So you'll need three different equations to solve it. But usually, if it's a simultaneous equation question, you can tell what are the patterns we're looking for. It might not even say 1 and 2 here. It might not even say 1 and 2. So you just got to be keeping a lookout for either two separate equations with, two variables in there we're trying to solve. That's what we're looking for, right? So we've done this. Now the methods I'm trying to discuss today. I don't really need to remember the names, but they're called substitution and elimination. Now, firstly, substitution is the easiest one. Now, if you can do this, you're going to probably do this because we want to make our life as easy as possible in the exams. Now, you want to use when one equation is already easy to rearrange to get a pronumeral by itself, or it already has a variable by itself. So in this case, number 1 has y by itself. Now, because y is by itself, we can, as the method suggests, substitute into here. So you'd get 2x plus, and then because we use brackets because we're substituting, 3x minus 4 equals 11. And then we just have to use our simple algebra skills to get the x's by itself, and then equals something. And then I'll be done there though. This is one common exam mistake that people will forget. People will solve for only one variable, right? Say we just got, what's this, 5x. So we get 5x equals 15. And then you get x equals 3. So a lot of kids will be like, oh, I'm done. No, you'll only get 1 mark there. Because why? We have to see what y equals because you have to solve for the set of the variables. So let's substitute it back into one of the equations. We can choose 1 or 2, it doesn't matter. I'm going to choose 1. Y equals 3, and then we're using brackets to substitute. 3 times 3 is 9, minus 4, so y is going to equal 5. So that's the substitution method, guys. And I'll be just putting a box around the set of answers. All right, cool. And then forgetting to check by substituting back. So this is one thing students need to do as well. We've got these two answered. Let's check if the left-hand side equals the right-hand side. So let's substitute into, say, equation 1. 5. Y equals 5 equals 3. 3. That's what x equals. Minus 4. So we get 5 equals 9 minus 4. So that's 5 equals 5. So we know LHS equals RHS. So we've just verified our answer. So if you've got enough time, this is a really important step. All right, cool. So we've done those two things. Now, that's the first method. Notice how the algebra from here, it's all just algebra skills you've learned from younger years of 7, 8, and 9. But it's just the initial substitution, which is the technique that we're going to use, or we're using that first method. Now, the second one, elimination method, is when the equations aren't so easy to just get y by itself or an x by itself, right? Now, what do we want to do? We want to actually eliminate, as the method suggests, the pronumeral. So what we can do here is, I'm saying, okay, to get y by itself, I would have to do the 3x over, then divide by 2. It's going to be a bit ugly. What I'm going to do is I see the 2y and 4y are multiples of each other, or very similar. So what if I times the first equation by 2? So we're going to times whatever we do to one side, we must do to the other. So 6x plus 4y equals 32. And then I'm going to put this one under it as well, 2x plus 4y equals 14. Now, it's kind of, you can do a little, set this up like this. This is probably what you did in primary school when you were doing simple addition and subtraction. But I made a mistake because I'm not going to be adding. Why am I going to be subtracting? Because, as I said, I'm trying to eliminate a polynomial, so that's why I'm trying to subtract, because we're doing 4y minus 4y. In other words, they cancel. Now we have to minus the other things. 6x minus 2x is 4x. 32 minus 14 is 18, so 4x equals 18. And then x equals 18 over 4, or 9 over 2. Now, are we done here? No, we must substitute this answer back into one of the equations, which you can do in your own time. All right, cool. So that's how you do elimination method. Now, probably the more commonly assessed one, given they're probably going to put hard questions in the exam. So let's go over one more of that type. So this is another simultaneous equations. How can I tell what pattern am I looking for? Two equations, right? And we've got two variables we're trying to solve, so we can solve it. Okay, so let's try and eliminate it, because I'm looking at the substitution method. It's not looking very nice here. It'd be difficult to get x by itself, or at least ugly to get x by itself. So I'm going to try to eliminate. Now, what do I want to eliminate? What am I aiming for here? We're aiming for the lowest common factor of 15, right? So I've chosen, we're going to try to eliminate y. I'm seeing a 3 and a 5. I'm thinking 3 and 5 in my head. Let's just times them together to get 15, right? So I have to times the first equation, all of it by 5, and times the second equation, all of it by 3. That way, we have the effect of getting minus 15y and plus 15y. Know that I don't care about if it's positive or negative, in terms of they don't have to both be positive or both be negative. Why? Because we can just add them, right? So when we do our step here, I'm going to add them. Plus 15y plus minus 15y is going to be equal to 0. So that's successful elimination, as the method suggests, right? Great. So we get 44x equals minus 7. X equals minus 7 over 44. Are we done here? No. We must find the other coefficient y through substitution. So we're going to substitute back in. And the working out is a bit ugly here, but I think you can do a much more succinct job. So we're getting this, and then we're getting y equals 277 over 44. All right, cool. So the last thing I want to go over is not really interpreting worded problems as simultaneous equations. Now, let's think about what patterns are we looking for to determine if, it's a simultaneous equation. So let's read the question. Piggy bank contains only 20-cent and 50-cent coins. Okay, so in my mind, I'm thinking there's two different sort of variables, possibly. We've got this, there are 60 coins in total, and the overall value is 1860. Determine the contents of the piggy bank. So in my mind, I'm thinking, okay, we might have two different variables, A and B or whatever, and we've got maybe information to make one equation, 60 coins in total, and the word and would be suggesting another bit of information that we could use to make an equation, and the overall value is 1860. So it seems like we've got equation 1 somehow, and equation 2. That's the pattern I'm looking for, right? And we have to determine the contents in terms of how many 50-cent and 20-cent coins are there. This is where it's a bit more free form, and you have to sort of be practicing these questions and understand that the process involved. So what we're going to be doing is I've said it can be A and B, because we're trying to determine the contents. I know that we're trying to determine the number of 20 and 50-cent coins. So let's just say instead of A and B, we're going to say it's X 20-cent coins and Y 50-cent coins. We know there are 60 coins in total. So that would be suggesting that X plus Y equals 60. Great. Now, because we're talking about 50 cents and 20 cents, it's important to have the units in the same, right? So we're going to convert to dollars to cents. So we've got 18,600 cents, or 1,860 cents, right? Now, how have they got this equation? 20x plus 50y, right? So we're told the overall value is 1860 or 18,600 cents. Now, value, if you think about it, is the price of the coin, 20, times the quantity of the coin, X. We've got X coins, so 20 times X, plus the value of the 50-cent coins, which is the price of each coin, 50 cents, times the quantity, Y coins. And then you get the overall value of the piggy bank. Right, and we can simplify by dividing by 10, and we will get this. So we get seems like we've got two equations. Now, x plus y equals 60. What method am I going to use to relate these two equations? Because it looks very easy to adjust number one to make, say, x the subject of the equation, you can just bring y over here. So you get x equals 60 minus y. And now, because substitution is the easiest method, you can substitute x directly into here, right? Into this orange bit here as 60 minus y. So what they've done here, 2, and then brackets for substituting 60 minus y, and they've cleaned it up, brought the three y's together, brought the 120 over here, they've got y equals 22. Now, are we done? No, a lot of students will stop here and lose marks, which is, you know, a word of caution, obviously. So keep that in mind. We're not done. So we have to find the number of x coins or find the other variable, right? So we're going to use equation 1, which is given the total amount of coins was 60, x plus y equals 60. We're going to rearrange x plus 22 equals 60. So then when you bring the 22 over here, you get this one here, and we get 38. So always coming back to what the question is asking in these worded questions, it's asked for the contents of the piggy bank. So you want to, in other words, give the number of each 20 and 50 cent coins. And the verification is really important, right? So the best way to verify is verify the value. So the number of coins times its value. So quantity times price is value. And then 22 50-cent coins and the 50-cent value itself should equal the overall value of the piggy bank, which it is, which you can verify in the first bit of the question. Overall value is 8060. Great. All right, cool. So hopefully that made a bit of sense in terms of a couple of methods and a couple of things to look out for. So keep in mind, is the worded question suggesting I should use simultaneous equations? Don't forget to substitute back in terms of, so don't just solve for one variable, find both x and y, or a and b, or 50-cent and 20-cent coins, or whatever the question is suggesting. Yeah, all right, so I think that's it. All right, thanks guys.